Okay, well, welcome. We appreciate Ben Ramsey being here to give this presentation. HTTP is dead, long live HTTP2. And so I'll just turn over the microphone to Ben.
All right, I am going to use the microphone today, even though I normally don't really need one in a room like this. I think my voice carries well, but I'm kind of getting a little bit of like a sinus thing going on here. So bear with me. I will try to vary my voice so it doesn't sound monotone and drummy. I have already put my slides up for this, so if you like to follow along kind of from your computer instead of trying to read what's appearing on the screen. Sometimes the screens don't show characters very well, so you're free to go ahead and grab the slides and download them, follow along on your own computer if you'd like to do that. I'll leave that up there for just a second. All right. Like my little Swedish domain name there. All right. Hi, I'm Ben Ramsey. As was already mentioned, I am a web craftsman, author, and speaker. I'm a software architect at a company called Shootproof, where I build a software as a service platform for professional photographers. It helps them manage their studios and sell prints to their clients. I work remotely from Nashville, Tennessee. And I've also been around the PHP community for many years. I'm co-author along with Davey Shafik of the Zen PHP Certification Study Guide. Davey just put that out in its 3rd edition sometime last year, I think. So it's definitely updated for the latest versions of PHP, I believe. I founded the Atlanta PHP User Group, and I'm currently a co-organizer at the Nashville PHP User Group in, of course, Nashville. And I contributed the array column function to the PHP core, which is a tiny little feat there, but I'm really proud of that. And I also am the maintainer and author of the Ramsey UUID library, and also maintainer of the PHP League of Extraordinary Packages OAuth 2 client library. And this is the gratuitous we're hiring slide. I would be remiss if I didn't mention my employer. They let me take time to go speak at conferences and do these things that I enjoy. So I definitely am very, very gracious of them. And we're also hiring. So if what we do sounds interesting to you, we're based in Atlanta, Georgia. So if that sounds interesting to you and you kind of want to check that out, let me know afterwards. I'll be happy to talk. All right. I'm going to try to drink a lot of water during this. I think I'm just, the air here is so dry, I'm just dehydrated. And when you have a dry mouth, it is not easy to say HTTP a million times in a presentation. It just all runs together. So if it starts running together, you know, I'm very sorry. But HTTP is dead. Long live HTTP2. So first, a little disclaimer about the title. Despite the name of the title, this talk is just as much about HTTP1 as it is about HTTP2. I don't want to jump too far ahead of myself right now, but as you'll see, HTTP1 is still very important to the work we do as web developers. And additionally, I don't want to steal his thunder, but tonight, if you attend the Utah PHP User Group meeting, Davey Shafik will be speaking, and I think the title of his talk is HTTP2 and Asynchronous APIs. So he'll be diving much deeper into HTTP2 and its features and how you can use them in tonight's presentation. So when talking about HTTP, we've come a long way. Here it is, 2016. And I wanted to take a look back and give a little bit of a history lesson of where we've come from in the web. So let's take a look back at 1990, where Tim Berners-Lee at CERN in Switzerland creates the first World Wide Web server, and he first serves HTML pages. So HTTP is this protocol he created to do this. And he created, and he said it's going to be an ASCII protocol serving this content over TCP. And so anything that we do on the web, and our job, most of us are web developers, I presume, is done using this protocol. So that's why it's so important for us to kind of have an understanding of how it works. So the version of HTTP he uses here comes to be known as 0.9, and it was a subset of what later became the 1.0 draft. 0.9 is very simple. Oh, thank you so much. It only supports the get method. So as you can imagine, back then, the only people really using the web were academics, and they were using it to share knowledge. That was its primary purpose, and all they needed to do was read. There was no such thing as posting data or manipulating data over the protocol. Fast forward a few years, HTTP 1.0 continues in draft form, heavily influenced by a guy named Roy Fielding. As you might recall that name if you've ever looked at any kind of representational state transfer stuff, or REST. Roy Fielding is the person who wrote the doctoral dissertation where we get the term REST. And this continued in the IETF working group. Moving along, the 1.0 version of HTTP was published in 1996 as RFC 1945. Now you can imagine at this point, in fact, PHP 1.0 came out like a year before this. And so the web, as you're thinking about it, is a really young place. Things are happening quickly, but it's still very formative. This version expanded the methods and headers, but it did not do something that we take for granted today. It did not support the host header. Now, what would be the important reason for the host header? The host header has the domain name in it, yes?
Virtual host, or virtual domain?
Yes, virtual domains. So if you don't have a host header, then your web server software can only serve one site per IP address. And so that's why the host header is so important. So the host header was not in 1.0, so only one domain per IP address. Yes?
Do I get a prize?
You can hold RAR for a little bit.
This is so special.
I meant to introduce RAR at the beginning, but RAR is a little stuffed animal I carry around and take pictures of him and share them with my son back home. So only one domain could be used per IP address. So then in 1997, HTTP 1.1 comes out. It's published as RFC 2068. Now, that's a little weird, right? Because we've been tossing around this number 2616 for like 15 years now, 16 years. But 2616 didn't come along until a little later, but it was still 1.1. So here we have a lot of new headers, a few more methods, and this is the version that we really kind of have been talking about all these years. But then we fast forward to 1999, and there's a refining and a clarification of 1.1. Several headers and methods that weren't widely implemented, and if you can only imagine, this is only 2 years, right? 2 years have passed, but they've decided there are certain methods and headers that just aren't being implemented widely in servers or in clients, so they decided to remove them from the specification. And these, some of the methods they removed are the patch method, the link method, and the unlink method. Now these later got added back in as part of things like WebDAV, if you've ever heard of WebDAV. So this is the version of HTTP that stood frozen in carbonite for about 15 years, over 15 years. But, a few little things happened along the way. In 2000, we got RFC 2817, which is titled Upgrading to TLS where they want HTTP 1.1. This helped us, advance SSL and secure websites. But, there wasn't a whole lot that happened within the intervening years. Until 2007, when the IETF, the Internet Engineering Task Force, decides to reform the HTTP working group, and they call it HTTP BIS. And we'll come back to this in a few minutes to talk about that working group and why they were reformed. In 2010, we start seeing a little more things picking up in the HTTP realm. A new RFC comes out that's just talked about defining well-known uniform resource identifiers. And I'm skipping over a few things that were a little in between. Then in 2011, we have an RFC that refines and clarifies how to use the content disposition header. right? The content disposition header is that one where you can prompt a file download with a file name and so forth. And then in 2012, we have some additional status codes added. So as you can see, like HTTP is not static, it's not dead, it's moving along. But no one is updating the old one. Until June 2014, what the HTTP BIS working group set out to do is to refine and clarify HTTP 1.1, which was RFC 2616 for 15 years, and they created a body of 6 different RFCs that are 7230 through 7235. We'll go through and kind of look at the highlights of what each of these RFCs do and what they clarified and changed. So you get an understanding of what that means for you. And then in May of 2015, all that work culminated as HTTP2 was finalized as RFC 7540. So when I talk about HTTP being dead, I don't really mean that HTTP itself is dead. I mean, RFC 2616 is dead. So in articles and blog posts and when we tweet and otherwise talk about RFC 2616, we no longer need to mention that number. We need to change our numbers and get used to saying 7530 or 7531 or however you want to approach it, or just HTTP. So again, this was created in June 1999, so it's pretty old. Here's the big deal about it, though. This was a massive RFC. This was probably one of the biggest RFCs ever published. If you go read any of these RFCs on the IETF website, I don't mean HTTP, I mean just any of the others, they're almost all short and compact. They deal with tiny little things. They deal with tiny implementations. HTTP was ginormous. And as a result, it was hard to read through, hard to sift through, and they also had lots and lots of errata and ambiguity. Here's an example of one thing that was ambiguous and that I've actually dealt with in helping people, with questions. And that is, can a GET request include a body? And if so, what does that mean for it? Like, can the server accept that body? Can you do something with it? And the answer is ambiguous. Some servers will accept it, and then you can read it. If you receive a GET request from PHP, you can read the body. Other server software, and I can't remember which ones, I think Apache might not allow it unless you change some setting, or used to not allow it. But in other implementations, you just couldn't get access to that body. Someone could send you the body, but you couldn't get access to it from PHP. So it's really ambiguous about what to do in those kinds of circumstances, things that just weren't clear. And the web got much bigger than anticipated. So as you can imagine, in 1997 when they published HTTP 1.1, and then in 1999 when they refine it and clarify it, this is just the moment when that big Silicon Valley bubble is starting to build up and grow. And then, we could never have anticipated this proliferation of APIs that happened like in the mid-2000s, right? Or like, around 2004, 2005, when Web 2.0 erupted. Everyone was creating APIs. APIs were everywhere, and they were all built on top of HTTP. And so the creators of HTTP, the authors of this RFC, could never have envisioned that. And as a result, HTTP got used in ways that they had never imagined. And so they needed to come back to it and look at how people were using it to refine and clarify and even remove a lot of the ambiguity that we see, or that people have. So HTTP BIS, what does BIS mean? BIS is the Latin adverb for two. So it's like the second HTTP working group. Or if you think about adverbs, the little rule of thumb in grade school, when you talk about an adverb, you add ly to it. So this is the HTTP working group 2 lead. I thought that was fun, but no one thought that was fun. It was chartered in October 2007 to refine and clarify HTTP. Here's the big deal about it. They were specifically forbidden from creating a new version of HTTP. This was a quote from their charter. Whoops, I just skipped ahead. What happened? All right. The emphasis here is mine. The working group must not introduce a new version of HTTP and should not introduce new functionality or add new functionality to HTTP. The working group is not tasked with producing new methods, headers, or extension mechanisms. And this was in 2007 in their original charter. They were only there to clarify and refine HTTP. And what do I mean by that? So remember when HTTP got clarified in 1999? And so you moved from RFC 2048 or whatever that number was to 2616. And they removed things like the patch header and the link header. Well, they were set to do that here. They were going to take a look at the headers that we're using. If there was anything that no one was using, they'd remove them. Any methods, remove them. They were specifically not supposed to introduce new ones. And then they wanted to clarify things to remove ambiguity. So that's what they're tasked with doing. But as we know, these are the 6 RFCs that they produced. So I'm actually going to go through each one of them. We're just going to hit highlights on them, and I'll tell kind of what got put into these RFCs. So these are all much smaller and tighter and more compact than the original ones, and a lot of advantages come from having each of these as separate RFCs. It means that if they need to change one of them in the future, or obsolete or update one of them, they don't have to update all of them. They can only update the pieces that matter. So the first one is the message syntax and routing RFC, or well, 7230 is the new 2616. So the first one is the message syntax and routing. This is what defines how HTTP goes across TCP. This is really kind of at the very low level, the nuts and bolts of everything, and it also kind of defines how the URL structure looks. Things that we don't really have to concern ourselves with a whole lot because we take it for granted that it just goes over the network as it's supposed to. But there are a few things that might be important to us. The first thing is that user info is now disallowed, explicitly disallowed. And user info is that part of the URL that includes a username, password, and then an @ symbol, and that comes before the domain name. If you've ever seen that, I don't think we do it a whole lot anymore because it's highly discouraged to do this, but this is how you do basic authentication in a URL without the browser prompting you, right? You go ahead and have the username and password in the URL, and then the browser doesn't pop up like the username and password prompt. The problem with that, I think, should be pretty evident, and that is it's in a URL. URLs tend to get cached in places, and you can paste them into message forums or whatever, and now suddenly everyone has your credentials to this, to whatever it is they're trying to access. So it's now explicitly disallowed in the URL. That just means it has no semantics. Like username and password don't do anything if you put them in a URL now. Another thing that might be important is that multi-line headers are now deprecated. So if you've ever seen things like, remember, how many of you have done like OAuth 1 programming? All right, so like if you've ever seen an OAuth 1 header, like an authentication header, authorization header, it's like many different lines of header code. And now that's been deprecated, so you should now put them all in one line. This is an important thing. This kind of paves the way for HTTP2, and that is that HTTP1 specified that clients should only have at most 2 connections to a website or to a server. Well, we break that all the time, and most of the clients never follow that rule. Most of them would allow maybe up to 6 connections at a time running. I think that number's right. And then on top of that, to get around the browser connection limit, we would do domain sharding, right? So you'd have multiple domains serving all your different static assets. That way, your site appears to load faster because you can have more connections open at a time to load all these assets. So they've removed that limit. There's a good reason why they removed it. And then there's a new term that you might be interested in knowing. It's a pretty super simple term, but if you hear it or see it written anywhere, it's effective request URI. What that means is in a typical HTTP request, you'll have your path here, and then a host name, and in this case I'm adding the port number too, even though the port number may not necessarily be there. And the effective request URI becomes, voila, this whole line. I mean, that's pretty obvious, but it's a new term that they've added to the specification that has some semantic meaning around it, and with more complex examples, it builds up that URI properly. All right, 7231 is the RFC that is probably the most important to you. This is where all of the semantics go. This is where your request headers, this is where your request methods, your response headers and response status codes, they all are defined in this RFC. So a couple of things to note about this, and that is that safe methods now have some more strict requirements. So if you recall, a safe method is something like get and head. These are safe methods. That means they should not have any side effects on the server. And in HTTP 1.1, that's basic, or I'm sorry, in RFC 2616, that's basically what it says. It just says a safe method is defined as a method not having any side effects on the server. Well, they go on to have almost a full page or two dedicated to what a safe method is now. And they've added things like, they've explicitly added options and trace as being safe methods now, because even they were inherently, or I'm sorry, implicitly safe, even though they didn't say it in the original. And they've now defined them as essentially read-only. They're not using that side effect word anymore. They're just saying a safe method is a method that is a read-only method. You're just getting data from the server in some way. And they say that, they explicitly say user agent should, and they use like this convention of should being in all caps, meaning that in most cases it should be this way. There are circumstances where you might opt to do differently. But user agents, your browser, should make users aware if an action that they are about to request is possibly unsafe. So like a post method, for example, or a put method. The content range, oh, I'm sorry, I'm jumping ahead. I mentioned this earlier, body is now allowed on GET requests. Now, they don't say that that means anything. They say that that's up to you. And again, GET is a safe method, so it's read-only. But what this allows you to do is, let's say that you've got some really long search query string. Putting that into a URL itself as a query string parameter might get too long, and some browsers might cut it off. Some browsers have limits to how long a URL can be. They're pretty long, but let's just say for the sake of example that you're posting something really long, or you're getting something with a parameter that's very long. Now you can put that in the body as maybe form encoded URL string, or URL encoded form string. And that way, the server can then read that body and then parse that as your request parameters. Content range is banned on put requests, mainly because it just didn't make sense. So if you were ever doing that, then like it's now banned. And then the expect header is no longer extensible. Now the expect header is something that got looked at a lot by the REST community, mainly because in Sam Ruby and Leonard Richardson's RESTful Web Services book, came out a few years back, they used the expect header in certain examples and then referred to it as a look before you leap request. So you could say expect :100-continue, and then instead of the server reading the rest of the body of your post request, for example, or put request, it would look at the headers and then should make a determination of whether it can continue based on the header data. So maybe you're trying to post a content type that it can't fulfill, right? And then it should respond accordingly, like 100 continue. Go ahead and send the rest of the request. Well, the problem is that most servers just completely subverted that. You could never get access to that first request from PHP, for example. You could never see the expect header, because Apache would see that expect header and immediately respond with 100 continue, because Apache could parse it. So your application had no access to that to be able to make a determination of whether it could continue. Originally, they meant for this to be an extensible header, so 100 continued was not the only thing, like it could have other expectations, but ultimately, because people were misusing this and there were widely broken implementations, they've now just said it's exactly what we've specified it, no extensions allowed to expect one to the expect header. I tried doing that look before you leap thing in an example in a talk once, and I had never tested it, and that didn't go over well. I wasn't like doing a live demo, I just was explaining, hey, you can do this. And then someone came up to me later and said, I've tried doing that and I can't do it, why? What am I doing wrong? And then I went and tried to do it and I was like, oh, because Apache doesn't give that header to PHP. Anyway. 201 now allows for more resources, one or more resources created. So the 201 status code means created. Now it could mean that more than one resource was created. 301 and 302 may rewrite from post to get. This is important because in the original specification, these are, of course, redirection headers, right? 301 means moved permanently. 302 now means found, but it used to mean moved temporarily. And they changed the meaning of the word to found for good reason. So you can cache that header. I'm sorry, 302 is not cacheable. So it just means I found the content, here it is, and the location could change each time you make a request. So 301 is cacheable. The reason they have noted this now, that you may rewrite from post to get, is because every single browser would take a 301 response or a 302 response, and take the location header and do a get request to the location header, redirecting the browser after the request was fulfilled. What it was supposed to mean was the location of the resource that you are making a request to has moved. Change your request to the new resource location. So if you were making a post request to a resource and you got back a 301 or a 302, then the browser should have redirected that same post request to the new resource. But in practice, no one ever did that. So 301 and 302 have now been said this is allowed explicitly in the specification, because previously we didn't explicitly say that was allowed. Now, 400 is another thing. 400 is a status code that means bad request. And in APIs, a lot of times, we'll use this as a generic status code. But in RFC 2616, it says that it's for syntax errors, malformed syntax in the request, which doesn't necessarily mean it applies to malformed API request data, right? So now they've basically clarified that 400 is a general status error code, and you may use it for whatever you want. And then they've added this one, 426 upgrade required, and this is so that the server can tell the client that they want to upgrade to HTTP2, for example. Some more things. All of these are now cacheable without explicit freshness. The location header may use relative URIs. Previously, they were supposed to be the full URI. In practice, people used relative URIs and browsers knew what to do with it. But now they've explicitly said that you can. These are the cool important things. 7231 sets up a method registry. 2616 did not have a method registry. So I showed you several other RFCs along the timeline that were adding new methods or adding new headers, for example, and adding new status codes. They've now explicitly set up registries to extend HTTP without having to update or modify this RFC, right? So now HTTP is very extensible, and anyone can really propose a new status code or a new method or a new header and create an RFC for it, and then when that RFC gets accepted, it gets added to this registry. I have links to the registries in the presentation. And then the content MD5 header was removed. This might be important if you have an API or that uses the content MD5 header. And that's because, the reason they removed it is because it was inconsistently implemented, especially with respect to partial responses. So the content MD5 header was a header that allowed you to have an MD5 hash that allowed a client to tell whether or not the content had changed between requests. So if that hash changed, then they knew that the content had changed. And it's kind of like an E-tag header, for example. But E-tag headers are better than content MD5, and people would use different hashes if the content was partial content or different content types. And so it was unclear like what that hash meant. Like whether it was the state of the document, like the state of like this kind of nebulous concept of a document, or the state of just that representation itself. And as a result, they just decided to remove it. All right, 7232, I'll breeze through these. This is conditional requests, so anything that you've ever done with like a range request. There are some changes that they've made. I just mentioned content MD5 header as being too ambiguous and widely misunderstood. Well, they've clarified the E-tag header as applying to the selected representation. So if you have an API that returns multiple representations of the same resource, maybe one representation is XML, maybe one is JSON, maybe one is HTML, all for the same URI. If you include an E-tag header, that E-tag is applied to just that representation. So the E-tag header can vary based on the content type that you have. They defined precedents for evaluation of things like if match and if modified sense headers. Moving on to 7233, which is range requests. So this defines range requests and partial responses. And so these are important for things like APIs or static content, like if you want to just get part of an image or load an image in bytes or chunks. They have redefined content range as only having meaning with 206 or 416. 206 means partial content, and 416 means range not satisfiable. So the content range header that is included only has meaning for those two responses. And the reason for that is just because it doesn't make sense for anything else. So they just needed to explicitly say that. They have included a range unit registry. This is very important. People were using the, what header was it? People were using range responses. There's I can't remember the header name off the top of my head, but it would indicate that what you were getting back was bytes, right? And that's all HTTP defined, just the bytes response. And so a range would be for like 0 to 1,000 bytes, and then the next range request would be for 1,001 to 2,000 bytes, for example. And I didn't specify that the type of range was bytes. People started extending this by saying the type of range is items. So in an API, for example, maybe my range is I want to get items 1 through 20, and you get back a JSON response that's items 1 through 20. So they're using this for pagination. But there was no real mechanism for the extension of the unit registry right here. So now they've added a unit registry so that people can propose new RFCs to add new things like items, for example, as a range. And then they've also added this multi-part byte ranges content type, which allows you to return a response as a multi-part response, and each part can be a range of bytes. But you could also just have one of them in your response. So if you're like chunking up an image, but you want to send back multiple chunks within the same response, you could do that. All right, caching. They haven't done a whole lot to caching, but they did do a substantial clarification to meaning of the directives. And they've also deprecated this thing, which caused a lot of confusion, the pragma header. I don't know, who's ever used the pragma header? So like, that goes way back. I remember using this almost 20 years ago, and the reason you'd use it is most browsers didn't support it, but IE did. So now that IE is up to date and actually more advanced in some respects than other browsers in implementing these standards, the pragma header is no longer necessary, and IE doesn't respect it anymore. There used to be a 1-year limit on the expires header. They've removed that limit with a caveat that just says, use your best judgment, and maybe things shouldn't expire, or should be fresher than 1 year. But if you need to have a limit on it for 2 years, you can now. There's a cache directive registry, and that has things like, there's all these different cache directives that you can specify when using the cache control headers, and now the registry allows that to be extensible. And there's also warn codes for the caches, and they've created a registry for that. Authentication is, this supersedes RFC 2617, which was for basic and digest authentication. And we have struggled with this for many years now, because there's always these questions of, well, what authentication mechanism should I use? And there's now OAuth, but how does it fit in with the HTTP authentication mechanism? Well, this now, this RFC, again, opens the door for a lot more extension to the specification by creating registries. The realm is no longer required on challenges, but the important thing here is that there is now an authentication scheme registry that they've created within the Internet Assigned Numbers Authority. So all of these registries have been set up, and in fact, that's my next slide. So the key thing, I think, in all of the clarifications and refinement to HTTP 1.1 is this registry notion. Now we have registries for headers and methods and status codes, range units and cache directives and authentication schemes. And this allows anyone to go through the IETF process to propose extensions to this by adding new items to the registries. And that's in fact what they want to do. If you've ever seen headers that say X dash some name, that became a pattern that people used in order to specify their own headers. But the problem is that now we have all these X headers, we don't know what they mean. Some people have seen an X header and they're like, that sounds like it does exactly what I want to do, so I want to attach my own meaning to it. And the different people using them have varied their meanings on what that header means. So now what they want you to do is, if you are in a company or are working for yourself and you're building an API or you're building something on top of HTTP and you need to create a new header for something that you're doing. Well, first of all, you can go look at the registry, and every header ever created is in the registry, and with links to its specification, so you can go read its meaning. Additionally, if you need to create a new one, then you go ahead and create one without the X in front of it, and you start using it, and you yourself can now draft a proposal to add that method to the registry and go through the process. That doesn't necessarily mean that it will get accepted in there, but the idea is that they want to discourage this proliferation of numerous X dash headers, because they lose meaning over time, and they lead to, what they really do is they lead to inoperable code or inoperable implementations. The whole goal here is interoperability. Did I say interop? They lead to uninteroperable. Is that a word? They lead to implementations that don't interrupt. And the whole goal here of any standardization practice, any RFC, is for interop to be at the highest point it can be. And then following 7335, we've got a whole slew of more RFCs. So basically the whole 7230 series is like the new HTTP 1.1. So 7236 sets up the authentication scheme registrations. It goes ahead and takes the authentication schemes that we've already seen throughout all these different RFCs that have come out, puts them into one RFC, and basically just says these are now in the registry. So that's what it does. Method registrations does the same thing. It cataloged all these extra methods that were out there and put them all into one RFC and says these are now in the registry, and so forth. Oh, and we've added a 308 permanent redirect. So earlier, I mentioned 301 and 302 having explicitly allow their browsers and clients to do GET requests on the location header that comes back. Well, a few years ago, a 307 temporary redirect was added, and now a 308 permanent redirect is added, which we think would be weird because we already have a 301 moved permanently. But what 308 does is it explicitly says if the request is a post or a put or some other request other than read-only, then you need to prompt the user. Then when I send this back and say this resource is moved, either with a 308 permanently or a 307 temporarily, what you need to do is take that location and assume that that's where the request should be going now. So if it's a post request, it now needs to go to that location, and the browser should prompt the user and say, are you sure you want to post to this new location because that's what's about to happen? And the reason it needs to prompt the user is so that things like if they have authentication credentials in there and now they don't trust the new location, they can decide not to post it to the new location. And then finally, there's a forwarded header, which is cool, and then something that I kind of think is really cool is this prefer header. It'll be interesting to see how this gets used. But here's 2 examples of what they have already. And this is, again, extensible. So the idea is to add more preferences. In this case, I'm posting to a collection. And so posting to a collection should create a new item in that collection. And I have a prefer header that says respond async. So respond-async is one preference. And I'm telling the server that I want you to go ahead and just respond right away to my request, whether you can fulfill it or not. Just go ahead and come back to me because I don't want to be waiting on you to process it. Okay. Okay. And so in this case, it comes back with 202 accepted, and it says that there's a preference applied. This one is return minimal, another preference, and basically just tells the server, I just want a minimal representation. You don't have to give me the whole representation back. And again, these are only for servers and services that support these kinds of things, but you can get this idea that you can allow your users, if you're building an API, for example, or some big web service, you can give them options to specify preferences in the data you send back to them. Now let's get back for a little bit to this HTTP BIS working group. They've worked to refine and clarify HTTP. They've migrated from one monolithic specification to 6 sizable specifications, and they've paved the way for managing new extensions easily through the registries. So in 2007, remember, their charter says they must not introduce a new version of HTTP. Well, lots of things changed since then. In 2009, Google announces their Speedy Protocol project to increase the speed of the web. In 2010, they released Speedy support in Chrome for all versions of Chrome 6. In 2011, now we're still dealing with Google here, Google deploys Speedy across all of their Google services. But then in 2012, something big happens. Twitter and Facebook and WordPress.com all see great advantages in using Speedy. They see browser support increasing, at least among their users, because a lot of people are using Chrome, and so they deploy Speedy in their services. This is huge, and the IETF is not blind to it. They decide something's going on here. We really can make a change to HTTP, and so they amend the charter. The new charter, I'm not going to read the whole thing, but basically they're admitting, hey, the web is changing, and there is a need for changing the protocol, the messaging protocol. So now your charter is to create a new major version of HTTP. And really the first draft of HTTP2 was the Speedy specification with find and replace made on all instances of Speedy to replace it with HTTP2. I mean, I'm not joking. That's basically what they did for the first draft. So in May 2015, RFC 7540 is published, defining Hypertext Transfer Protocol version 2. Now, why HTTP2? I'm going to try to speed through this because I'm too slow in the first part, I guess. There are some problems we face in HTTP today. And the working group realized, as they saw increased interest in speeding and proven results from using it, that's important, that the TCP binding protocol for HTTP, a new TCP binding protocol for HTTP was possible, while still maintaining the semantics that we're all used to. That's why HTTP1 is still so important. That's the semantics. HTTP2 changes the messaging framework. So the first reason is that we were having inadequate use of TCP. HTTP is an ASCII protocol over TCP. That's not very efficient. And even while using TLS, which is encrypted, the packets, they felt, could be sent in a much more efficient manner. Another thing is that transfer sizes and number of objects per request is exploding. Every page we build now tends to have more and more objects on it that need to be requested. In fact, this is just looking back over the last 5 years, 4 or 5 years, and we were seeing, and this comes from Daniel Stenberg's book, HTTP2 Explained, we were seeing this increase in transfer size to almost 1.9 megs per page load, and the objects are going up as well. The number of images and assets that you have to load. And that's not going down, it's only going to continue to increase. We've also seen that while bandwidth has improved overall across the globe, latency still has not improved. So the time it takes for a request to complete has not improved, despite the fact that people are getting on faster internet connections. HTTP pipelining problems. In Daniel Stenberg's book, he describes HTTP pipelining as like waiting in a line at a soup bank or a supermarket. You just don't know if the person in front of you is going to be a quick customer or that annoying one is going to take forever. And once you get in a line, you can't get out of line. You could create your own line, but that might not work. So this is called head of line blocking. And that happens in HTTP pipelining, and it's so bad that browsers, most browsers just don't have it turned on. So you can't take advantage of HTTP pipelining. So as web developers, we've learned to deal with all these issues. And we've written at length blogs and books and articles and given talks and created training courses. We've created a whole industry around these problems with dealing with HTTP to solve them. One of the ways we solve them is through image spriting, right? Because it's better to deliver one humongous image than it is to deliver thousands of tiny little small images. And this goes back to that whole connection problem, right? You deliver thousands of tiny images, you're going to have to open tons of connections, and so your page is going to load slower. We've taken to inlining images and CSS and SVGs because we want to reduce the number of requests we make per page load. Concatenation and minification. We want to reduce the size of the payload going over the wire. And then domain sharding. So if you look at like all of these domains, like Facebook has tons of different domains it's using to deliver all of its assets, so it can try to improve and deliver faster. HTTP2 attempts to fix these problems. So it uses a binary protocol, which sounds weird because we're used to that ASCII protocol. We can just fire a telnet session and type in the commands itself. But we won't be able to do that in HTTP2, but we'll have new tools that will help us do that. And the reason for this is it will be easier to find the beginning and ending of frames. So the new messages are packaged with these frames. And they're arranged into binary frames. Each frame has some similar properties. There are 2 frames. There are 10 different frames, but 2 that are specific to our semantics of HTTP, HTTP1. There's a data frame and a headers frame. And these are all like packaged up into these multiplex streams. And so the beauty of the multiplex stream in HTTP2 is that a stream can have multiple requests going through it all at one time. It's like a train. And each request, you think about it as like a car in that train. And it doesn't matter what sequence they're in, though, because within the stream, they're able to, each frame is able, or each package in the frame is able to define its priority and dependencies. And so when it gets to the endpoint, then it can, the server or the client can look at those priorities and dependencies and say, have I got that other frame yet? Oh, I haven't, so I gotta wait on that. Or where does this go in the middle? So like it then arranges it. So going across the wire doesn't matter what order they're in. And that sounds a little bit inefficient, but it's actually much more efficient. It gets the things across the wire quicker and then allows the client and the server to kind of handle all of that. Another thing is header compression. So headers take up lots of space. Headers also tend to be redundant on requests. A lot of requests are the same headers. Now with HTTP2, we'll be able to compress the headers and also reuse headers across different packages. And then finally, server push. And I think this is what Davey's going to talk about a lot tonight. So come to his talk to hear about server push. The server will be able to push data to the client. It can make intelligent decisions. The really cool part about this is that if a page request normally has other images, like if a single request tends to be related to other requests, like maybe you've got images that load on that page, the server can intelligently figure that out and go ahead and start sending that data before the request comes. All right, so great, how does that affect me? Well, mostly it's seamless. I'm trying to skip through this. But all these things that I've talked about will no longer really be important to our jobs as web developers. But not so fast. We can't jump ahead and just do those things because we're still living in an HTTP 1 world. So I'm going to go ahead and close right here. Folks are catching up. So a lot of browsers are supporting HTTP 2, but it's still only at the bleeding edge. A lot of servers are now supporting HTTP 2, but it's still, again, at the very bleeding edge. So for now, you're going to have to keep using some of those HTTP 1 tricks for a little while longer, but give it a couple of years, and I think that we'll start seeing a lot of our sites that we use switching over to HTTP 2. Until that is HTTP 3. And that's actually being discussed now. So I'm going to go ahead and close. I will be out in the hallway if you want to talk to me. I'll let the next person come in and set up. So thank you very much for your attention and for attending my talk.